Hi, everybody. Welcome back. My name is Weston Bussler, and this is my second talk. And if this is the first one that you're seeing, I encourage you to go look at the first one covering the GI microbiome and digestion. But for this talk, it's all going to be in regards to precision prebiotics and every day to advance support. For the GI, there are all sorts of different stimuli that are really able to disrupt the state of GI homeostasis. And I outlined this prior, but there's all kinds of different microbes that inhabit our GI. They're genetics. They make up what's called the microbiome. And each individual's microbiome is different, and it's very influenceable. The microbiome is not static. It's very plastic. It can change ever so slightly. It can change rather drastically, but it's always trying to return back to that center. However, there are all kinds of different things that are capable of disrupting this homeostasis. So antibiotics, diet, hygiene, prescription drug use, short-term, long-term travel, gastrointestinal stress, lifestyle. Then there's all sorts of things that affect the development. You have lifestyle things that are completely unchangeable. But these ones up here, these are all modifiable. So those are the ones that we're focusing on for this. But then what can happen in this is actually your microbiome, within your microbiome stability, after it's been established as a healthy, stable state, certain disturbances that can put it into this transient degraded state for a long enough time, there's not a complete recovery achieved, even though that's what's trying to happen in your body, because this healthy, stable state, it resists this colonization and it adapts overall to help maintain this species-rich, complex in what it can do metabolically, and it's inflammation sensitive. So what you wind up seeing is if this disturbance, this acute disturbance, is not completely recovered from, you have an incomplete recovery, you move to what you would call some kind of degraded stable state. So if these persistent stressors are great enough, then all of a sudden that threshold's passed and you have this new state, and this state is what actually starts to become that baseline. It resists colonization by other microbes that would be otherwise healthy and beneficial for you, and it retains it. Even if you start going more towards what would be a stable state, it'll still want to try to snap back to this degraded state. So maintaining that homeostasis is incredibly important. And all these different things, right, are able to modify that either temporarily, or if that temporary state gets to persists too great, then it can wind up becoming that new normal. So then this altered intestinal microbiota is associated with compromised immune defense. And immune defense overall is just an incredibly important feature of the GI. And it's also associated with chronic inflammation, metabolic dysfunction. These are also interacting with one another. And then you have certain things like leaky gut, all of that tied to that intestinal microbiota being altered. Looking at the microbiome, various substances are capable of affecting it. You can affect the population, you can affect the targeted particular groups, you can affect the overall proportion of a group, but there's these various things that directly either feed the growth of beneficial bacteria, prebiotics, or they're just more general to changing microbes. They can be affecting the overall diversity. Things like fermentable fiber really can impact that diversity. But then they could be substances that are just introducing new microbes that themselves interact with the microbes there. That would be where probiotics can really impact it. Certain things like antibiotics and vitamins and proteins and fats also are capable of impacting the microbiome. On the prebiotic side, you have certain substances like CLA and PUFA. As well, you have various phytochemicals and phytobiotics that can change it. But then more specifically, the traditional prebiotics would be a lot of the oligosaccharides, the fructooligosaccharides, the lacto-oligosaccharides. And one particular group of oligosaccharides that is very, that's coming to fold for its importance is the human milk oligosaccharides. And human milk oligosaccharides, they're incredibly important for infants. This has been identified in infants as something called the fitness factor, and it feeds the growth of good, beneficial, symbiotic species. It's also something that is now getting some interest in the adult nutrition space. Overall, prebiotics, there's 3 necessary criteria. So they should be non-digestible by a host enzyme. They're fermented in the GI tract. They have selective stimulation of gut microbiota and metabolic activity. There's a demonstration of criterion. It's difficult. A prebiotic is not available to all bacterial species that inhabit a GI ecosystem. So Lactobacillus and Bifidobacterium are considered indicator organisms known to have a beneficial relationship with the host. It's important that they're feeding these ones that are identified as good bacteria or good overall microbes. Naturally occurring or synthetic sugars, starches, all sorts of various sources of these can be prebiotic compounds. And they just, once again, they have to be utilized as a source for certain beneficial bacteria for growth and metabolism. So one example would be inulin, fructooligosaccharides, another galacto-oligosaccharide, or so inulin is also a form of fructooligosaccharides, as well as something like lactulose. Additionally, that novel prebiotic human milk oligosaccharides are unique because they're more targeted in their approach on how they work. Prebiotics work in interacting with human health in a number of different ways. They directly feed the growth of beneficial bacteria, so Bifidobacteria and Lactobacilli. Those then produce a lot of antimicrobial substances. They themselves are pathogen inhibitors. The pathogen inhibition occurs from these antimicrobial sources. They provide fermentation products that can be changed and into the generation of something like a short-chain fatty acid. So these probiotics ferment things into postbiotics, as well changing the lower luminal pH, which that has an effect on pathogen inhibition. And then in addition to that, you have altered microbiota composition and altered metabolite profiles. So altered immune system interactions, effects on specific conditions like IBS, IBD, C. diff, as well improved defecation patterns for patients. Looking at the microbiome, one of the things that can be utilized now more than ever are these microbiome analysis tests. And when you are trying to identify the specific targets that should be looked at for an individual, this is the census of everything that's living in the GI. You have two ways of looking at them. You can look from the most diverse, the highest 1,000-foot view at the phylum level and look at those proportions. But you can also look at the more specific genus species level. Then you can derive things like a total diversity score for a population and then try to really figure out how this diversity compares to what would be a baseline of what have been deemed healthy individuals. As with the various microbial populations and specific species that are inhabiting an individual. It's an important tool where you can identify something where an individual has a range of microbes that could potentially be far higher or far lower than the general population. So for instance, there's a pretty big range in a lot of these, but for some individuals, the group of actinobacteria can range from 0 to almost 20%, with a median around 0.6%. So there's a lot of people that actually have a really, really low amount of them. You don't necessarily want to see too many of them. It's important to have an overall diverse set of microbes in the GI. But if you do outline a specific area to target, be it lack of firmicutes or too many Bacteroides or just overall diversity loss, there's a way that you can start targeting it. But then some individuals will have too many of one species or another, such as Proteobacteria. A lot of Proteobacteria actually can be pathobiomes. And if this is too high in individuals, it can signal some kind of an issue. So what you would want to do is not directly feed these Proteobacteria potentially with the units that you're giving. This is why a lot of people experience some problems if they have a dysbiosis, if they're overfeeding their bacteria. As well, if there's a particular group missing, so say somebody is missing all of their Actinobacteria species. This is a very important group of beneficial microbes, and there's just very, very few, almost none. It's an area that you can target with a particular kind of prebiotic. This novel prebiotic, that group of novel prebiotics that I've been referring to, the human milk oligosaccharides, they're these compounds, shorthand known as HMOs. They're extremely important in the infant diet, helping to feed good bacteria, particularly bifidobacteria, and they confer benefits to immune health, as well as many other areas of infant nutrition. They're a main driver of the superiority of human milk or human breast milk versus infant formula. They directly feed the growth of good bacteria. They are very selective, contrary to other oligosaccharides, because specific enzymes are needed in order to digest them. But one additional thing that's been identified in infants is how these infants, they have very undeveloped GIs. Their immune system hasn't fully matured. And one of the theories behind partially why these are so beneficial is that these HMOs can act as decoys for microbial adhesion to infant intestinal cells. And they're structural ligands for microbial produced exotoxins. So the microbes actually will bind a lot of these and mistake them for binding sites, to then become unavailable for their ability to adhere to the GI. So when you look at the population studies with infants that are breastfed, you see lower rates of a lot of these microbial derived conditions that stem from these different interactions. Of particular, in these HMOs, one of the ones I want to outline here is 2FL. 2FL is the most abundant of these oligosaccharides by amount in breast milk, and very recently it's been able to be produced in large amounts, and it's something that is now being moved out of just infant studies into research into adults, and how adults can utilize large amounts of this substance in order to display a lot of this prebiotic effect. So why are these compounds so special? Well, they are so specific to just a few good bacteria. If you look here, I've outlined a few bad bacteria as well as good bacteria, two different select types. And then what you'll see with the bad bacteria is we've also collected info on the various simple sugars like glucose, lactose, and how those are able to feed directly nearly all of these different, actually all of the species listed here on this slide. But when you start to look at prebiotics, something like galacto-oligosaccharide, you see some specificity to the bad bacteria and a really diverse feeding effect on all of the good bacteria. So it's feeding lactobacillus, acidophilus, lactobacillus, paracasei, and all of the different bifidobacterium listed here. But in contrary to this, 2FL is different. 2FL is hyperspecific towards not being able to be broken down by these bad bacteria. So they don't contain the same enzyme necessary to break that bond with this enzyme is called fucosidase. They can't break that initial bond. And what happens then is not all microbes are able to consume this readily. In many cases, it can hang around a little bit longer, not be as quickly metabolized. And then what you see is only a small subset that do express this ability cleave that initial bond and are able to consume this readily. When this has been tested in humans, now that we've been able to synthesize large amounts of it, a study by Eliason et al. In 2016 outlined that in a placebo-controlled trial, that 5 grams daily of 2FL for a 2-week period was able to very targetedly increase the proportion of actinobacteria in the microbiome. Now, in these individuals, what was seen in the placebo was no change in comparison. And why this is so important is that Actinobacterium phylum, it encompasses many beneficial bacteria, including bifidobacteria, but it's also an important group of microbes for GI homeostasis. So this grouping, this phylum of Actinobacterium, it's been implicated in all sorts of health benefits. So for individuals that are missing it, there's a lot of benefits that they could be missing out on because of the way that these specific microbes contribute to health. Now, that's not the only reason that 2FL, so just this microbiome effect, it doesn't just stop at, oh, the microbes increase. Those microbes do things, and they do a lot of different things. And one of the particular ways that it works is it may support that immune system function. So for this, prebiotics, they feed the specific commensal microbes. And these commensal microbes are so important to the immune defense. They help train the immune system. They help to have direct effects, beneficial bacteria, direct effects on the other microbes. So microbes are coming in trying to colonize, but then the good microbes are known to support the defense from this. One group grows out of proportion that it should, good microbes help control that. And then there's all sorts of things that they produce in addition to that. In animal trials, recently in adult mice, what's been found is that when you stimulate a colitis model, so you're creating a highly inflammatory, problematic GI environment. But when they give them 2FL, and 2FL in comparable amounts to what would be seen in these human trials, the amount of, or the 2FL that's fed to them is actually helping to attenuate a lot of the problematic damages that you would see in a control mouse where no therapy is given. So supporting the GI barrier overall with more tight junction protein. So strengthening that barrier overall when the GI is challenged in that state. Increasing mucus production when the GI is challenged. So helping to coat that barrier nicely, as well modulating the immune response, helping to control the expression of excess cytokines that can stimulate immune responses throughout the body, or as well helping to just control tightly the response to what needs to be done and not be excessive. It's really an exciting and evolving area of research on how 2FL may be supportive to this immune system defense. And one area that I've mentioned earlier that's been really well outlined in infants. It's this incredibly unique ability of these human milk oligosaccharides to perform a decoy function to the various microbes that are trying to colonize on the GI. In that extension of the infant immune system, what you see is that these microbes actually will mistake those oligosaccharide compounds for those surface-bound sugars where they would bind on the GI sites. And then as they bind, they become unable to initiate their colonization and move through. So you have this effect, and it's a really exciting area to consider of how the immune system can be supported external to just the microbes being themselves feeding off of these prebiotics. Additionally, you see that these act as a ligand to a lot of the bacterial exotoxins that are being created. So it's just supporting all sorts of areas of the immune system. Prebiotics have been outlined as being able to do this, but 2FL and human milk oligosaccharides, they just have this extremely unique ability, and it's an area of really, really exciting research right now. So I hope that you were able to take away just how exciting these new human milk oligosaccharides are for their potential both therapeutically and just as a nutritional component. That targeted prebiotic working with all sorts of other therapies as a new tool in the toolbox to target a lot of these GI specific and whole body effects coming from the GI.